Good morning, children.
Good morning, ma'am.
Good morning, children.
Good morning, ma'am.
Good morning.
Good morning, ma'am.
Good morning. Good morning, children. Have we discussed all the expressions in this question number 1?
No, ma'am. You gave 1, 2, and 3 as homework, and we did only 4 in class, ma'am.
This is homework, this is homework, this is homework, and we did 4 in the class.
Yes, ma'am.
I remember doing this also. No problem, no problem. Okay, so 1, 2, 3 homework, and 4th one was done in the class. Fine. You've taken a screenshot of the answers, right, to check the homework answers?
Yes, ma'am.
Ma'am, we have taken all the screenshots of the answers, ma'am.
Yeah, I remember that also. Yes, I remember something like that. I think I'd asked you to complete all the 8 questions.
Yes, ma'am.
Okay, let it just be a revision. Let us do from the 4th one. So in the 4th, we have 49y square plus 84yz plus 36 z square. So there are 3 terms which may be of the form a square plus 2ab plus b square. So we would like to check on that if these 3 terms can look like a square plus 2ab plus b square. So a square plus 2ab plus b square has 2 perfect squares, a square and b square. Here also we have 2 perfect squares, 49y square and 36z square. Because 49y square can be written as 7y the whole square, 7y into 7y, 49y square. And 36z square can be written as 6z the whole square. Because 6z into 6z is 36z square. And now let's check on the middle term, 2ab. So it will be 2 into a, which is 7y, and b, which is 6z. Because a square is 7y the whole square. So a is only 7y, b 6z. Because this is b square, 6z the whole square is b square. So b 6z. So when you check 2 7 are 14, 14 6 are 14 6 are 84. Multiply and check 14 into 6. Okay, 84. 84 yz. 84 yz. It's happening. The middle term is also happening. So that means, so you have to first check if the expression has 2 perfect squares, a the whole square and b the whole square. And using the expressions or the values of a and b, you must check the middle term, 2ab. 2ab. If all these happen, then the given expression is of the form a square plus 2ab plus b square. So the given expression is of that form. So the answer is a plus b the whole square, which is 7y plus 6z the whole square. So 3 terms, 2 perfect squares, 2 perfect squares. So step 1 is to write 49y square as 7y the whole square, 36z square as 6z the whole square, and then the middle term 2ab. And this 2ab works to 84yz. So the given expression is of the form a square plus 2ab plus b square, and the answer is a plus b the whole square, where a should be treated as 7y and b should be treated as 6z. So the answer or the factors of the given expression are 7y plus 6z into 7y plus 6z. What do we mean by 7y plus 6z the whole square? 7y plus 6z into 7y plus 6z. 7y plus 6z the whole square, meaning 7y plus 6z into 7y plus 6z. In the next expression, we know the golden rule while factorizing is if all the terms involved in the expression, have HCF other than 1, 1 is always common between the terms. So other than 1, if the HCF of if the HCF of the terms involved in the expression is something other than 1, then you must first bring out that HCF or the common factor, the highest common factor. That's the first step which you should always do while factorizing. So in the fifth one, we have the expression which reads 4x square minus 8x plus 4, where the HCF of all the three terms is 4. The HCF of all the three terms is 4. So take out 4 common. Take out 4 common. 4 into x square is the first term, 4x square. 4 into minus 2x is the second term, minus 8x. And 4 into 1 is the third term, plus 4. 4 into plus 1, plus 4. So we first take out 4 common. Everywhere we should do that. See here also, not that here we did not take out. Here also there's nothing. The HCF of all these three terms is 1. The HCF of these three terms is 1. The HCF of these three terms is 1. So it's not that everywhere, wherever the HCF is something other than 1, you should bring out the common factor. The HCF is the common factor. So 4 common and the expression looks like this. That's the first step. Now, don't worry about the 4. 4 is simply going to come out as it is. Look at the expression inside the bracket. X square minus 2x plus 1. Here we have two perfect squares. X square is x the whole square and 1 is 1 the whole square. X square is x the whole square and 1 is 1 the whole square. And the middle term formed using x and 1 is 2 into x into 1. The middle term formed using a and b. A is x, b is 1. The middle term formed using a and b is 2 into x into 1, which is the middle term in the given expression also. Which is the middle term here? See, it's 2x, minus 2x. So the expression in the bracket is of the form a square minus 2ab plus b square. In the bracket, the expression is of the form a square minus 2ab plus b square, which should be written as a minus b the whole square, where a is x and b is 1. So you can see again in this, the last step, 4 as it is. What we have in the expression, what we have in the bracket can be written as x minus 1 the whole square. So 4 into x minus 1 the whole square. Any doubts with the fourth and fifth one, children?
No, ma'am. No, ma'am.
No, ma'am.
Okay, Raja, explain the sixth one. Raja. Devadarshini, can you explain the sixth one? Who wants to explain the sixth one?
Shall I explain?
Yes, Danya.
Ma'am, here the expression is in the form of a square minus 2ab plus b square, ma'am.
Okay.
So 121 can be written as 11b square because 11 into 11 is 121 and 16c square can be written as.
Sorry, Danya, sorry. Now, which are the two perfect squares in this expression?
11b perfect squares are, ma'am.
In the given expression, yeah. No, in the given expression, the question. Which are the two perfect squares?
121b square and 16c square, ma'am.
Very good. How can you write 121b square as x the whole square?
X the whole square because we can form the square of 121, ma'am, which is 11b square, ma'am.
It's not 11b square, it's 11b the whole square.
Oh, sorry, ma'am. 11b
Yeah.
the whole square, ma'am. And
Okay.
16c square can be written in the form of perfect square as 4c the whole square, ma'am. Because
Okay.
4 into 4 is 16.
And c into c square.
Yes, ma'am. And
Okay.
here we can get
What is x from this? What is x
yes,
from this?
X
We are
is
now assuming that it is of the form x square minus 2xy plus y square. We are just assuming. We don't know if the middle term will happen. If the middle term doesn't happen, we cannot use this identity.
yes, ma'am. And
Yeah.
here X is 11b and Y is 4c, ma'am. So
Yeah.
here X, we take in the place of 11b the whole square and 2ab is minus 2 into a is 11b and b is 4c, ma'am.
Y is
And
4.
plus,
Y is 4c.
yes, ma'am. And
Why
then
sign here? Why minus sign here? Why not plus?
because the expression is 121b square minus 88bc.
Minus, this minus, very good, very good. Yeah, correct. Okay, now is the middle term happening?
Yes, ma'am, it's happening, ma'am.
Very good, very good. Okay. Yeah, continue, Tanya. Yes. So it looks like the given expression is of the form
A square minus 2ab plus b square, ma'am. Here
let's
it
say
is like
x squared minus 2xy plus y square.
yes, ma'am, x square minus 2xy plus y square, which
Okay.
is x minus y the whole square.
Very good.
And
So
then by equating, we get that so it is 11b minus 4c the whole square, ma'am. 121b square minus 88bc plus 16c square is 11b minus 4c the whole square, ma'am.
very good, Tanya. Excellent explanation. Thank you.
Thank you, ma'am.
All right. Same question, children, the 7th and the 8th one. So here in the expression we have, 11, sorry, 1, oh my God, L plus M the whole square minus 4 LM. L plus M the whole square minus 4 LM. That's the given expression. That is the given expression, L plus M the whole square minus 4 LM. So what we have to first do is we'll have to first expand this. We'll have to first square this. It's L plus M the whole square. Square it. What will you get? It's like A plus B the whole square. A plus B the whole square is A square, L square, B square plus M square plus 2AB plus 2 into L into M. So first square L plus M. Square L plus M. L plus M the whole square. See, if it is in the form A plus B the whole square, the answer will be A square plus 2AB plus B square. Now we have L plus M the whole square. So it's like A plus B the whole square. So if it's A plus B the whole square, the answer will be A square plus 2AB plus B square. So L square plus 2LM plus M square. And that minus 4LM as it is. This one as it is. That's the first step. That is the first step. The first step is, in the expression, we have L plus M the whole square. We'll first expand this. We'll first expand L plus M the whole square. It's L square plus 2LM plus M square using the identity. And this minus 4LM as it is. Now you can see plus 2LM minus 4LM. They're like terms. So you can simplify them. So you get L square plus 2lm minus 4lm is minus 2lm. L square minus 2lm. L square minus like terms, simplifying the like terms. Minus 4lm plus 2lm is minus 2lm. And then this term as it is m square. Now this expression has three terms. The middle term is negative. And we have two perfect squares, L square, M square. We have two perfect squares. So we're just checking if it's of the form a square minus 2ab plus b square. So let's write L square as L the whole square, M square as M the whole square, and the middle term is 2 into L into M, because L no, A is, this is A and this is B. And if you see, it works, the middle term works, 2lm minus 2lm. So by the identity a square minus 2ab plus b square, the result is a minus b the whole square, where a is n and b is n. So this is nothing but L minus m the whole square. L minus m the whole square. So write the given expression. The given expression L plus m the whole square minus 4lm is equal to L minus m the whole square. So this you will learn as an identity in higher classes. This is an identity. The identity is a plus b the whole square. You can make a note of it. 1 minute. A plus b the whole square minus a minus b the whole square is equal to 4ab. A plus b the whole square. Supposing you're given the value of a plus b, some number, a numerical value for a plus b, and you're given the value of ab. You can substitute in the equation and find the value of a minus b. The three expressions involved in this identity are a plus b, a minus b, and ab. A plus b, a minus b, and ab. Children, am I audible and clear?
Yes, ma'am.
Okay. So a plus b the whole square minus a minus b the whole square is equal to 4ab is a very important identity where we have three expressions, a plus b, a minus b, and ab. So we have three expressions. Given the values of any two, you can find the third one by substituting in this equation. Given the values of any two, maybe they'll give you a plus b, the value of a plus b and a minus b, and you'll be asked to find the value of ab. Any two, you can find the third one using this identity. Now you just transpose. Now you just transpose. Bring this one here and this here. It will be a plus b the whole square minus 4ab, because it's traveling to the other side. 4ab travels to the other side. So it will be a plus b the whole square minus 4ab is equal to minus on the other side. Right hand side will become plus, is equal to a minus b the whole square. Correct? Let's transpose these two terms. A plus b the whole square. A plus b the whole square. Now 4ab from the RHS is traveling to the LHS. So it will come to the LHS as minus 4ab. And minus of a minus b the whole square is traveling to the right hand side. So that minus will become plus. The minus in front of a minus b will become plus because it's moving to the RHS. So it will be is equal to a minus b the whole square. So a plus b the whole square minus 4ab is equal to a minus b the whole square. That's what is here also. Here it is. Here the identity, we have understood it using a and b. Here the result is in terms of L and M. L plus M the whole square minus 4LM is equal to L minus M the whole square. The identity is here in terms of L and M. Let's wait for 2 minutes. Just go through the solution for the 7th one and also the identity which we just discussed. And make a note of the identity. Is it good, children? Understood clearly?
Yes, ma'am.
Yes, ma'am.
Okay. Let's see the 8th one. So in 8 again we have 3 terms. 1, 2, 3 terms. When we have 3 terms, we first want to check if the expression looks like the identity. So since we have A and B in the given expression has A and B, we'll use the identity as x plus x square 2xy y square. We'll use x and y. We'll use x and y because the identity already has A and B in it. So again, this expression has 3 terms. 3 terms, of which 2 terms are perfect squares. A to the power 4 is a perfect square. See, when do you call a term a perfect square or an expression a perfect square? See, now this one is a perfect square because you can write it as something the whole square. If you can write it as something the whole square, it's a perfect square. What should come in the bracket?
A square, ma'am.
1 second, children. Harini. Yeah, so we've been saying perfect square, perfect square. So how do you make out it's a perfect square when you look at it? See, now you know that a to the power 4 can be written as something, the whole square. What is that something, children? I think somebody answered.
A square.
A square. Whatever you can write anything. But when you simplify, you should get a to the power 4. That's all. Don't get confused like there's a square outside, there's a square inside also. Nothing like that. A to the power 4. How can you say it's a perfect square? Because I can write it as something the whole square. I can write it as something in the anything in the bracket, whole squared. If it gives you a to the power 4, then it's a power 4 is a perfect square. So here in the bracket, we need to write a square. Similarly, b to the power 4 is a perfect square because it can be written as b square the whole square. B square the whole square. So that's it. See here. A to the power 4 can be written as a squared the whole square. B to the power 4 can be written as b squared the whole square. And using, see, this is take out the squares. So this is your x and this is your y because this is x squared. This is x squared. Take away the square. This is only x. A square is x. Take away the square. This is y. So 2x. 2 in, say just writing and checking if it's of the form x squared plus 2xy plus y squared. It may not work also. If it doesn't work, just strike it out and we have to do a different way. Maybe we have to split the middle term. If it does not work, strike it out. That's all. So I was telling that there are 3 terms and 2 perfect squares. So write the perfect squares like this and check on the middle term. The middle term is 2xy, where x is a square. How do you know x is a square? Because this is x. In the bracket is x square. In the bracket, what you see is y square. So what I've circled are x and y. So 2xy, 2 into a square into b square. Does it give you the term which we have here? Yes, it does give us 2a square b square. So yes, it's of this form. And the answer is x plus y the whole square, where x is a square and y is b square. X plus y the whole square. This is the answer. Any confusion? Whatever question you have in your mind, children, ask me. Nothing?
No doubts, ma'am.
No doubt, ma'am.
All right. Fine. So now again, the heading is factorize. Look at the first expression. It has only 2 terms. It has only 2 terms. Tell me the identity which has 2 terms, either in the LHS or RHS. See, let's recall all the 3 identities we know. So we know that we know a plus b the whole square, a minus b the whole square, children, which has 3 terms on the other side. Oh, it's black. I'm not able to see. So we know that a plus b. What is a plus b the whole square?
A square plus 2ab plus b square, ma'am.
plus 2ab plus b square.
And what is a minus b the whole square?
A square minus 2ab
A
plus
square
b
minus
square,
2ab
ma'am.
plus b square. B square.
And what's the other one?
A minus b the whole square, ma'am. It's equal to a minus b into a plus b.
A minus b the whole square, no? No?
A square minus b square,
minus
ma'am.
b square, ma'am.
Yeah,
A square minus b square.
correct. A squared minus b squared can be written as a plus b. So when we were factorizing these earlier expressions, we used either a square plus 2ab plus b square or a square minus 2ab plus b square. So since the given expressions were like this, we gave the answer as a plus b the whole square or a minus b the whole square. See, if you're asked to expand 3x minus 7y the whole square. So the given question looks like a minus b the whole square. If they say expand 3x minus 7y the whole square, then it looks like a minus b the whole square, because there are 2 terms here, like this is a and this is b. And it's like a minus b whole square, like this. So the question you should identify. See, an identity has the question and answer in it. If the given question looks like the left hand side of the identity, the right hand side of the identity is the answer. 3x minus 7y the whole square looks like a minus b the whole square. So the answer is a square minus 2ab plus b square, where in place of a you should use 3x and b you must use 7y. That's all. You select the identity so that you can get the format for the answer. What is the format for the answer?
Excuse me, ma'am.
Yeah.
Ma'am, in the first sum, since both 4p and 9q has a square.
Yes, Madhumita, I'll ask you when we come to that. Yes.
Yes, ma'am.
I'll ask you. Yeah. So, yeah, so to expand 3x minus 7y the whole square, it looks like a minus b the whole square. So the question is like a minus b the whole square. So the answer is a square minus 2ab plus b square. That's the format for the answer. That's all. In that expression, instead of a, you must use 3x, and instead of b, you must use 7y. Simplify and give the answer. That's all. Yes, Madhumita, you want to say about the first one? Tell me.
Ma'am, I actually wanted to ask a doubt.
Yeah, please. Yes.
Ma'am, can we also write it as 4p minus 9q the whole square?
Okay. Let's say that even I don't know, so we'll just check on that. Okay.
Yes, ma'am.
Now you're saying, for example, we have 5 square minus 4 squares. You're asking me if you can write as 5 minus 4 the whole square. Is my question? Have I understood you right?
Yes, ma'am.
Now, when we get so like this, we'll get in different situations, we'll have different kind of confusion if this can be worked like that. So you should always take a numerical situation. Now here the answer is no, it's not possible. But still, if I say yes or no, you just have to take it like that. But if you experiment it yourself, you can do it in any other situation where you get a similar doubt. So your doubt is if a square minus b square, like 5 square minus 4 square, can be written as 5 minus 4 the whole square. Am I right?
Yes, ma'am.
Yeah, why I have used numbers is because you can simplify them. Now, what is 5 square minus 4 square? Tell me the answer. How do you simplify this 5 square minus 4 square?
Ma'am, 5 plus 4 into 5 minus 4, ma'am.
Okay, no. Otherwise, we don't know the. Okay, that also will give the same result. You don't know the identity. How will you do? You are in 7th standard. You don't know the identity. Then how will you do?
Ma'am, the other a square minus 2ab plus b square.
No. What is 5 square? What's the value of 5 square?
25, ma'am.
25. What's the value of 4 square?
16, ma'am.
What is 25 minus 16?
9, ma'am.
9. Now, 5 square minus 4 square is equal to 5 minus 4 the whole square only if you get the same answer here also. You should get the same answer 9 here. Correct?
Yes, ma'am.
But what's the answer here? 5 minus 4 is 1. 1 square is 1. Are the answers the same?
No, ma'am.
Clearly, a square minus b square cannot be written as a minus b the whole square. Maybe in some situation the answer might match, but that doesn't mean you can take something as true only if it is true for all situations.
Okay, ma'am.
Yeah. Now maybe this will work. Now, for example, 1 square minus 0 square. Let's try this. And 1 minus 0 the whole square. What is 1 square? 1. Minus 0 square 0. 1 minus 0 is 0. Oh, sorry, 1 minus 0 is 1. 1 minus 0 is 1. And here 1 minus 0 the whole square. 1 minus 0 is 1. 1 square is 1. Yeah, here it works. This doesn't mean that a square minus b square is a minus b the whole square. It doesn't work here. If it works, it should work everywhere.
Okay, ma'am. Now I get it.
Okay. So children, a minus b the whole square is not the same as a square minus b square. is not the same as a square minus b square. They're different. Okay. Yeah, the first one in this. The first one is, we have two terms. We have only two terms. So it looks like a square minus b square. Why it looks like a square minus b square? Because there are only two terms and both are perfect squares. There are two terms and both are perfect squares. Correct?
Yes, ma'am.
So you write it as I'm going to discuss everything and then show you the slide. So we write it as 2p the whole square minus 3q the whole square, because 2p the whole square is, we write this as is this correct?
Yes, ma'am.
So given question is of the form a square minus b square. So the answer is
A plus B into A minus B, ma'am.
a plus b into a minus b. So what's the answer? What is a?
2P, ma'am.
And b?
3Q, ma'am.
3q. A plus b, 2p plus 3q into 2p minus 3q.
Yes, ma'am.
How many are there on this slide? 4. Oh, 4. The first 4 and then I'll show you the slide. The next one, 63a square minus, that's it. The first one is fine, that's it. 4p square minus 9q square can be written as 2p the whole square minus 3q the whole square. And they are of the form a square minus b square. So the answer is a plus b into a minus b. That's the answer. 2p plus 3q into 2p minus 3q. That's the answer. That's the answer. Finished. And the answer is sensible. It's meaningful because the two factors, factorize meaning you should find the factors. That the two factors of the given expression are 2p plus 3q and 2p minus 3q. The two factors of the given expression are 2p plus 3q, 2p minus 3q. Okay, the second one, 63a square minus 112b square. Now when, so 4 and 9, what's the HCF for 4 and 9? What is the HCF for 4 and 9? 1. They have nothing in common. Am I audible and clear, children?
Yes, ma'am.
Okay.
Yes, ma'am.
4 and 9 have only 1 in common. The HCF of 4 and 9 is 1. But what about the HCF of 63 and 112? We'll find. We'll find. Whenever we have numbers like this, we should first check their HCF. If their HCF is 1, you can ignore it. If it is not 1, if it is something other than 1, we need to take that as the common factor. 63 can be, see, you can do this method also. So what's the HCF, children?
7, ma'am.
63 has 3, 3 and 7 in it. 112 has 2, 2, 2, 2 and 7 in it. What is the HCF? Sorry, what is the HCF?
7, ma'am.
7.
7,
Is, yeah, 7 is the HCF of 63 and 112. A square and B square, there's nothing common. A square, B square, Nothing is common between them except 1. So leave that. 63 and 112, 7 is common. So I've told you the golden rule. Whenever we have to factorize an expression, if there's something in common between all the terms, bring out the common factor. So 63 a square and 112 b square have 7 in common. Bring it out. Open bracket. Watch now. I don't know what to write. Tell me, children.
Three.
9a square.
What?
Ma'am, 3 into 3 into A, ma'am.
No, that's what the final answer. 3 into 3 into 8 into A. But what's that finally? 9a square, correct?
Yes, ma'am.
Minus
16 b square, ma'am.
16b square.
B square, ma'am.
Because you take away the 7s. You take away the 7. So 3 3s are 9. 9a square. And take away the 7 from here. So it will be 2 to the 4, 4 to the 8, 8 to the 16. 16b square. Because 7 is brought out common. So cancel 7. The remaining numbers you find the product and write it inside. Is it okay?
Yes, ma'am.
Yes.
And a square, b square, you know why 9a square and 16b square, you know that. 7 9s are 63, a square, minus 7 16s are 112, b square. Now, how many terms we have in the bracket? 2 terms. Are they perfect squares? Are perfect squares?
Yes, ma'am.
Yes, ma'am.
3A square and 4B square.
Yeah, that's it. So 3a the whole square minus 4b the whole square, which is like a square, which is like x square minus y square. So in the next step, write it as x plus y into x minus y. Third one is simple. Fourth one, children, what is common? Find the HCF of 16 and 144.
Ma'am, 4 is common between that, ma'am.
Only 4, huh? Check.
Ma'am, 16 is common, ma'am.
16 is common. I don't know if anything else is common. Take out the common factor and tell me what you get in the bracket.
Ma'am, 2 into 2 into 2 into 2, ma'am.
Yeah, now tell me like 9a square minus 16b square. Work it and tell me.
Okay, ma'am. Ma'am, 16 into x to the power 5 minus 9x cubed, ma'am.
No, I just wanted to think one step ahead. There's something else common. 16 and 144, 16 is common. What's common between x? What is the HCF of x to the power 5 and x cubed?
Ma'am, 1.
No.
Ma'am, 8, ma'am.
8. We are already done 16 and 144. 8 is common, huh? Class, use the emoji. Raise your hand. Sanjay and Sindhu, Raja, Madhumita, Danya, Kirtana, Devadarshini. All right. Fine. Kirtana, are you following?
Yes, ma'am.
What's the HCF of 16 and 144, Kirtana? Yes, what's the HCF of 16 and 144? You must have found something, right?
Yeah, 16, ma'am.
No, you should not ask me, Kirtana. You must tell me. Are you saying or are you asking me for the 16? Why, Kirtana? Yes, 16. You're right. Be sure of your answer. What is the HCF of x to the power 5 and x cubed, Kirtana?
What, ma'am? Can you repeat? X to the power, x to the power 5 and x power 3.
Yeah.
X power 3, ma'am.
HCF. LCM. I've told you. The smallest class, I've told you all that the smallest power will be the HCF and the highest power will be the LCM. See, supposing you have 1 by x square or x cubed plus 2 by x to the power 5. So LCM of x cubed and x power 5 is x power 5. And the numerator you will have x square plus 2. Why x square in the numerator is because x cubed into x square is only x power 5. X cubed into x square. Okay, so now tell me what's the in our days, you know, whatever our teachers told us in the class, we had the habit of taking running notes, whether it is a practical subject or a theory subject. When the teacher says something, apart from the answer she says, when she says something, we make a note of all that in our book. Because all this, see, everything we discuss in the class is completely new to you. We are not discussing science of 3rd standard or mathematics of 4th standard that you can just listen and leave it. Everything we speak in the class is new to you. Certain things like the question and answers from the textbooks or other books, you have them in your notebook. You have worked them in your notebook. Other things we discuss in the class. If you don't make a note of them, see now, at least one of you should have written this. Whatever is on the screen here. See this one.
Ma'am, I've written it down.
Yeah, you can just put a cloud somewhere in your book. You can just put a cloud, and inside the cloud, you can just simply write. You don't have to write any story. When you look at this, you will realize, oh yeah, the HCF and LCM. You will be able to recall this discussion. And you'll wonder why she's going away from the topic, why she's trying to do all this. Just make a note of this. It will be helpful. The second time you see this, it'll make more sense. Now when I say, it'll be like, why this, why that? But when you see this for the second time, it'll make more sense. You feel, oh yeah, yes, it is like this. But the other day I did not follow so clearly. When you visit the same thing many times, it becomes more clear. So simply draw a cloud, and if you write it, it's not catchy. If you simply write it somewhere in your book, you may not be able to make out that it exists in your book. You can use a different color pen, a red pen, draw a cloud with a red pen and write it with a black pen. So that when you turn the page, the color attracts you and you're forced to read the contents in that. So everything should be noted down. Otherwise, someday you will say in school MCQs, maybe you're asked a question similar to this, then you will say you did not teach us LCM and HCF at all. But how can I prove? I cannot find this recording and play it for you. Please make a note of all that we discuss in the class. So this is what it is. So when it comes to 16x to the power 5, 16 and 144 have 16 in common. X to the power 5 and x cubed have x cubed in common. This will be out in the bracket. X cubed into x squared is x to the power 5 minus 16 nines are 144. Close the bracket because x cubed is already here. 16x cubed into x squared. See, 16x cubed is the HCF of these two terms. The HCF of 16x to the power 5 and 144x cubed. Because 16 and 144 have 16 in common. The HCF is 16. X to the power 5 and x cubed is common. That is the HCF is x cubed. Open bracket. This would be x to the power 2. Because x cubed into x squared is x power 5 minus 16 nines are 144. Now inside the bracket, it's in form a square minus b square. So a plus b into a minus b. Yeah, work out the answers to the first 4. The first 4 questions which we discussed, you can see the answers here in this slide. Please work it now in the class. Write down the question, write down the given expression and factorize it. Are we writing?
Yes, ma'am.
Yes, ma'am.
Any questions as you write, please ask me, children. I'm right here.
Completed, ma'am. Completed, ma'am.
Okay, children. Let's finish 5, 6, 7, 8 also today. Now, the fifth one. The fifth one is of the form a square minus b square, where a is L plus m. See, cover the square. Cover the square. What you see is a. What the remaining thing which you see in the bracket is a. Cover the square. Because a squared minus b squared. So cover the square. What you see is a. L plus m is a. Cover the square. What you see is b. L minus m is anything can be there. If you have, these are two perfect squares. L plus m the whole square. L minus m the whole square. They are two perfect squares because they are raised to the power 2. L plus m the whole square minus L minus m the whole square, like a square minus b square. What do we have in a square minus b square? We have two perfect squares, a squared, b squared. We have two perfect squares separated by a minus sign. Same thing we have here. We have two perfect squares. Something the whole square, something the whole square separated by a minus sign. Identical, both are the same, both are similar. So a square minus b square we know is a plus b into a minus b. That is a plus b and a minus b are the two factors of a square minus b square. A plus b and a minus b are the two factors of a squared minus b squared. What is a? L plus m. B, L minus m. So the given expression L plus m the whole square minus L minus m the whole square will be, this is like a square minus b square. So a, see here, a plus b. See, this is a and this is b. Can you see my pointer, children?
Yes, ma'am.
Okay, so this is a, and this is b. A plus b, see, a. This is the answer for us. This is the answer. This is the format for the answer. A plus b, a minus b. This is the answer. Instead of a, you must write L plus m. Instead of b, you must write L minus m. So see here, a plus b into a minus b. Because a itself has two terms, you should put them in brackets, a and b. A, b, they themselves have two terms. So enclose them in brackets. The next step, open the bracket. L plus m. There's a plus outside, so plus into L is plus L, plus into minus minus m. Here, L plus m, the terms in the first bracket, they come out. Minus into L is minus L. Minus into minus plus m. Minus into plus L is minus L. When you multiply minus and plus, it's minus L. Minus into minus plus m. So here what happens? In the bracket, m minus m gets cancelled because 0. M minus m, 0. L plus L is 2L. Then L and minus L will get cancelled. M plus M is 2M. In the first bracket, M minus N, 0. They get cancelled. In the second bracket, L and minus L, plus L and minus L cancels out. So M plus M is 2M. So now 2L into 2M, which is 4 LM. Can you see, children? 4 LM. Now, can you recall the identity which we learned? A plus B the whole square minus A minus B the whole square is equal to 4AB. See here. We proved that. This is A plus B the whole square. This is A minus B the whole square. The answer is 4AB. Is the procedure understood, children?
Yes, ma'am.
Okay, take a screenshot and you can write it down later. We'll finish 6, 7, and 8. So the first thing in the sixth one is 9x square, y square, and 16 have nothing other than 1 in common. The HCF is 1. So you don't have to take out anything common because the HCF is 1. There are only 2 terms. You should always analyze how many terms are there in the expression to be factorized. How many terms are there? 2 terms. So if it has 2 terms, then it cannot be a square plus 2ab or minus 2ab plus b square. It has to be a square minus b square. So, and it is in the form a square minus b square. You can see that 3xy the whole square minus 4 the whole square. So a plus b into a minus b is the answer. It's simple, children. You can ask me if you have any doubts for the sixth one.
No doubts, ma'am.
All right.
No doubts, ma'am.
All right. Let's see the seventh one now. In the seventh one, children, when you see this bracket, I've worked in a different way here. Let me teach you in a different way. Oh, no, I've done it like this. Okay. Now this is the given expression, children. This is the given expression. What does this look like for you? This is the given expression. From here to here is a given expression.
AB plus B square, ma'am.
Don't you think this straight away a minus b the whole square? X square minus 2xy plus y square is what? X minus y the whole square identity. Yes or no?
Yes, ma'am.
So directly, that's the first step. The first step is to write. The first step is to write this one as x minus y the whole square. Because it's x square minus 2xy plus y square. So it's x minus y the whole square. And you can, and this minus z square is written as minus z the whole square. The first step understood?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now there are 2 terms. Both are perfect squares. X minus y the whole square minus z square. There are 2 perfect squares. X minus y the whole square and z square. So clearly it's on the form a square minus b square, which is a plus b into a minus b. There are 2 terms. This is like a square minus this is like b square. The first term looks like a square. The second one looks like b square. So it's a square minus b square, which is a plus b into a minus b. So how do we identify a and b? I've told you, just cover this, just take away the squares. Take away the square, this is a. Take away this one, this is a. And this is b. So what is a, children? A square is given. What is a from it?
X minus y, ma'am.
Yeah. What is b square? What is b square? Okay, what is b?
Is it, ma'am?
Z, ma'am.
Z. Yeah, then what is b square then? What is b
Z
square?
ma'am.
Z square.
Z square. Yeah, z square. Yeah. What is a square?
X minus Y the whole
Minus
square,
Y
ma'am.
the square, ma'am.
What is a?
X minus Y, ma'am.
All of us get that?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So on if you item, that's it. So the first step is to write x square minus 2xy plus y square as x minus y the whole square. The first step is to do this one, x minus y the whole square. Then the z square is z the whole square. So it's like a squared minus b squared, where a is this and b is this. So the answer is a plus b into a minus b. So for this question or for this expression, the answer is a plus b, a minus b. Or this should be plus or no, yeah. Okay, a children, see here a, x minus y is a, can you see it? A plus b plus z into a, x minus y minus z. This is a plus b into a minus b. Then open the bracket, x minus y plus z, x minus y minus z. That's it. Go through the steps for yourself.
Ma'am?
Yeah.
Ma'am, can you show the previous slide, ma'am?
Yeah, I'll show you the slide. Please tell me if you understand this answer 7. I'll show you.
Ma'am, I get it, ma'am.
Okay. Others children, yeah, one by one tell me.
It's clear, ma'am. It's clear, ma'am.
Ma'am, I understood, ma'am.
Okay. So there are two terms, x minus y the whole square, which is a square, and z square, which is b square. So from that you should get a and b, and write the, since the question is like a square minus b square, the answer is a plus b into a minus b. See the 8th one. Now the 8th one, children. It's a holiday, right? So you can wait, correct? I just need 10 minutes to finish the class.
Yes, ma'am.
Yes, ma'am.
Yes,
Please
ma'am.
do it. Yeah. Now, in the 8th one, we have 4 terms. 1, 2, 3, 4 terms we have. We have 4 terms. 1, 2, 3, 4 terms. And if you look at the last 3 terms, you know, they somehow look like this x square minus 2xy plus y square, because you can see b square here, c square here, and bc here. See, like x square, y square, xy. B square, C
Yes,
square,
ma'am.
BC. So we feel the last 3 terms can be grouped together. Why should we group the last 3 terms? Because they have this B square, they have C square, and the middle term BC. So we feel that these, see, you can do it in your mind. You can do this in your mind. What is 4b the whole? Forget the signs. The signs will match. Forget the signs. Just take 4b. 4b square. What is 4b square? 2b the whole square, right?
Yes, ma'am. Yes, ma'am.
And what is 49c square?
7C the whole square, ma'am.
7c the
Square.
whole square. Yeah, now you have 2b and 7c. What is 2 into 2b into 7c? 2ab. 2ab. 2 into 2b into 7c.
Yes, ma'am.
Don't we get 28 BC? 2
Yes.
into A into B. 2 into 2B into 7C. Don't we get 28 BC?
Yes, ma'am.
Yeah, that's why we are grouping the last three terms. Because the last three terms have two perfect squares. 4b squared, 49c squared, two perfect squares. And the middle term, you will get 28 BC with 2b and 7c. So we want to group the last three terms. What you do is you write 25s for the first term, you just write it alone like this. Then the sign here minus, you must write the same sign minus. Please follow 25a square, 25a square. Then it's a minus sign, so the same minus sign. Now what you should do is the remaining three terms you must enclose in a bracket. The remaining three terms you should enclose in a bracket. But there's a minus outside. So you will see that every term in the bracket comes with the opposite sign. See here, the term is minus 4b square. It will become plus 4b square in the bracket. This is plus 28 BC. It will be minus 28 BC in the bracket. This is minus 49c square. It will be plus 49c square in the bracket. Because there's a minus outside the bracket. Now when you multiply minus into plus minus, minus into minus plus. See here, minus into plus is this minus. Minus into minus plus. Minus into plus is minus. So what you do is you write the first term as it is. You write the first term as it is. Whatever sign is out here, whatever sign, if it's plus, you should put the same sign plus. Minus, then it's minus. Open and close a bracket, and inside the bracket, you must write these three terms with their opposite signs because there's a minus outside. So minus 4b square should be written as plus 4b square. Plus 28 BC as minus 28 BC. Minus 49c square as plus 49c square. Is the first step understood, children?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yeah. Now with the second step, you must write 25a square as 5a the whole square. And then show that this is of the form x square plus x square minus 2xy plus y squared. So this you understand. So this bracket, 2b square minus, that is this one, x square minus 2xy plus y square can be written as x minus y the whole square, correct?
Yes, ma'am.
Yes.
Yes,
Can
ma'am.
be written as x minus, so now this one can be written as x minus y the whole square. This one can be written as x minus y the whole square. So that's the identity I've mentioned here. X minus y the whole square is x square minus 2xy plus y square. X is 2b and y is 7c. So the given expression can be written as, see here, 5a square, 5a the whole square minus, what is this? What is this one? 2b minus 7c the whole square. This is x square minus 2xy plus y square. So x minus y the whole square. 2b minus 7c the whole square. The first term 5a square as it is. Now it looks like x square minus y square. X is, see, cover the square. X is 5a. Cover the square. Y is 2b minus 7c. X square minus y square. X square minus y square. So now the given expression can be written as, The given expression can be written as x plus y into x minus y. X plus y into x minus y. Open the bracket. So 5a plus 2b minus 7c, 5a minus 2b, because minus into plus is minus, minus 2b, minus into minus plus 7c. Now what you should do is, when you write down, this answer, don't write the identities in the middle. Just write the steps like, see, like, one, write this, write this, write this. Don't write this item. Don't write. No, you must write the identities. I'm saying, like, to understand, you write two versions. I'll also make the other version for your next class. Or if I prepare it, I'll share it on WhatsApp with you. What I'm saying is write these, then don't write these identities, because when this comes in the middle, it's kind of disturbing the flow of the answer. So don't write this. Don't write this. After this, write this one, this step. Don't write this identity. That disturbs the flow of the answer. Don't write these two. So write this one. Then after that, write this. Then after this, don't write the identity. Write this step, and then this, and then this. So then you will know what's happening in every step. The identity you can write beside. See, one version, no, don't write beside, it'll be too lengthy. One version, you make it like this, as you see in the slide. Then the next version, don't write the identity. Still, you have to write the identity for the exam. To understand better, just remove the identities from the middle and write only the steps which form the answer. I think that should be, when you look at that, it will be more clear. Because when you write the identities in the middle, it's kind of disturbing you from the flow of the answer. Is my feeling, you know, I would do that. If I didn't understand, then what I would do is I'll just write out only the steps without the identities. Then I'll just look at them, why the next step happens. Yeah, then you should insert the identities. Once you understand, then you can insert the identities. I'll have to try to make a new slide incorporating what I just said and share it on WhatsApp with you. Yes, children, now you need to complete. So take a screenshot. Somebody wanted, I don't know who asked. Yes, so this is the first one. Children, you have written this in the class already, but just in case you're not sure, you can take a screenshot of this one. This is the second slide. Homework. Done?
Yes, ma'am.
Yeah, this is the third slide.
Taken, ma'am.
All right. We'll discuss these in the next class, children, but I just want you to try it. Take a screenshot. Homework. This is homework. I have not explained these, but now with all the idea you have of this chapter regarding factorization, you should be able to understand with the help of the answer. But anyways, we'll discuss it in the next class. Homework. Take a screenshot, children. You can try it now. You might think why you're giving us the answers also. We'll try it ourselves. I'm giving you the answers, but you have all the questions, right? So meaning you have all the questions on one side. So you don't look at the answers. If you want to try it by yourself, you don't look at the answers. You try to do it yourself first, and then you check your answer with what actually the answers are. Yeah, take a picture. Homework.
Taken, ma'am.
Done, children?
Yes, ma'am.
Yes, ma'am.
Okay. So this is homework. Every time, so we have to start with, we'll have to discuss question number 3 and then continue with 4. Okay. All right, children. So that's it for today's session. Thank you so much. So today, today's class was a class in lieu of tomorrow's class. So tomorrow we don't have a class. Next we'll meet on Tuesday.
Yes, ma'am.
Yes, ma'am.
Yes. Thank you. Tuesday, can I make the class in the morning?
Yes,
Ma'am,
ma'am.
no, ma'am. I have school on Tuesday. We have only 3 days for winter holidays, ma'am.
Okay, okay, okay.
Ma'am, I also have school on Tuesday, ma'am.
Okay, fine, fine, fine. All right, then I think it will be the regular class in the evening. Okay, fine. All right, children. Good, I asked you. Yeah. Thank you, children. Yeah.
Thank you, ma'am.
Thank you, ma'am.
Thank you,
Thank
children.
you, ma'am.
Thank you, children.